Hi, this video is about how to system or acceptance test enterprise applications which use a REST endpoint. So in your enterprise application, you probably have unit or integration tests, testing your application in an embedded way or in a way that you only test single or several components at a time. But however, you should in fact have fully fledged system or acceptance testing your application in an end-to-end way. And earlier this year I wrote a blog post why this is important or why that should be done, and actually why both unit tests and fully fledged system, or also called acceptance tests, are very important for correct working software. And how to do this? So in order to showcase that, I wrote a simple Java EE application which returns coffee over REST and as JSON. And in order to do so, let's just build and deploy this project to show you what it does. And as it uses Java E7 in a plain WAR file deployment, it's very fast. And now we can access the application as it exposes REST and HTTP with any REST client of our choice. I will use the command line here just to show you how it roughly works. It's called coff EE, resources, coffees, and returns an empty JSON array in this case. And if you create a coffee via post and JSON content type, you can specify a type like espresso and an origin like Colombia. And now you create this, and 2.1 no content says that it was successful. And let's create another one from Ethiopia. And now when querying our and printing our endpoint, we see that both these coffees have been created via a link, which is done here. But now the interesting part is, so this application actually just stores that in a singleton and returns the created coffees. So that's very simple, just to showcase how that is system tested. And well, these single coffees can also be retrieved, of course, and also be deleted again. Very simple. So, but now how to system test this in an automated fashion? Because when you deploy your application, you want to make sure that it works in a certain way, and of course that it still works after introducing some changes to have regression tests. And in order to create a system test, I will use Java as well. Actually, you could use any kind of technology that accesses your HTTP endpoint, because that is the point you probably want to decouple your client from your server side, which means you could theoretically use any technology that understands HTTP. But as we are Java developers, I will of course use Java. So I'll create a new project, which is a Java EE project, just because I have an artifact script here prepared that creates a Java E7 project. And let's open this via IntelliJ. System test pom XML. I just created that project here, which uses my default Java E7 setup as a Maven project, but actually we don't even need this here. So I will delete and change the project type, as it only should run as a test. So actually we would later on run the test here as a project, and this is also the reason why I can delete everything on the Java side. We only need the test execution. And let's introduce some dependencies which we need on the system test side, which is JUnit, just because it offers a nice way to run tests and assertions, and JSON as a client dependency. I will use the reference implementation from Jersey, but actually it doesn't matter which client you use. I just like to use the JSON as a client because that is a standard and also known in Java EE projects, so also available and probably known to your developers how to use that API. And I think it's a nice API and really usable, and therefore I also use it for system tests and any other type of HTTP access. So let's create a test here. I call it coffee acceptance IT. IT for integration test, and the reason for that is that Maven via build will not run the IT tests automatically. So you won't run it accidentally, you have to run it with failsafe plugin. And now let's run a test scenario where we specify some tests against our REST API. And now the important part is that you probably should not want to write the tests like right away to start them code, but maybe to start with notes on paper or in an editor, and then derive the functionality you need on your test side. And the reason for that is that you very often just tend to start right away and mix both the logic that you want to test, like a test scenarios, and your implementation. So how that is accessed on your application side, which is not a good way to do this because you want to decouple these layers of abstraction, how your REST endpoint is accessed and how your test scenario, including your data, looks like. Because on a fully fledged acceptance test, you obviously test your application in an end-to-end way, and when things changes on your application, then you always have to change something on your test. And if you repeat yourself all over again and just write your test in a single method or a single class, then you mix both the implementation and your test logic, which makes it really hard to maintain and keep track of your test. And actually this is the reason why in my own client projects it was often just not implemented to do real acceptance tests, because the argumentation was that it would be too cumbersome and too hard to maintain. But actually, if you pay attention when writing tests, that can be done in quite a doable and effortless way. And the most important thing is that you think about the layers of abstraction. So actually, just to start with, let's write our test just in comments and in plain text, and then think about a good layer of abstraction later on. So, for example, from a business use case perspective, this is what you should ask yourself first. What do I want to test, actually? So we probably do not care about HTTP and status codes and the JSON format first. We should think as users, what do I want to do here in order to use the application? And therefore, create these scenarios up front, and then further on deep dive furthermore into the technology and how that is used. And a good way of doing so, or a good reason for that, is that you could then even change something on the layers below, like change your REST endpoint to an UI or to something else without needing to change your scenarios or your data. And that would be also helpful if you change something in your application. So let's start. For example, we want to verify we want to create a coffee first with some data. you can think of the data later, create another one, maybe another one, and then assert that the coffees actually have been created. And then, as we saw, we can also delete coffees again. So let's do that with maybe 2, and assert for a single coffee that it's not there anymore. So a few things up front: when you test all these things, you probably do not want to test them in an absolute way, like this here. If you create 3 coffees, that you assert that 3 coffees actually are there, because if your scenario is, or if your application is used in the real world, you probably have other users or other use cases at the same time running concurrently as well, and therefore you should think of how can I test that in a sufficient way, no matter what you test, but don't test too much or don't assert too much at a time, because then you get like failing tests, which are actually no real failures, which are just too strict in the way what they test. So let's extend that with data. For example, create a coffee with type espresso and an origin Colombia, what I did, and create a second one with Ethiopia, and create a third one with, let's say, a pour over coffee from El Salvador. And then you make sure that these coffees exist. I just reference them by a number for now. We want to delete these coffees again and make sure that they don't exist anymore. And then at the end, for example, we can make sure that the last one still is there. And now let's go a bit further. Let's write this actually as method names or as methods, because this is what I like in programming, when you have like a bigger problem and you have to, well, split it up and boil it down to smaller, simple problems or simple artifacts to solve. Then it's often very helpful to start with something like comments or just plain text, and then write your methods up front and deep dive further, which ensures you, I think, a higher or a better layer of abstraction. So just to get rid of these comments, because nobody likes comments, right? So let's delete them again. Let's create these methods of what I just wrote in the comment here. And this will be a method here in our test, a private method, which then makes sure that this is created. And actually, as we dive further later on, we also need to think about the types, the data types, which our method return. Which means if later on our client talks about HTTP and URIs and JSON, on this level we probably do not want such a low-level technology, such a low-level binding to some functionality. Rather than, let's do just a URI here, which means our resources later on are identified by URIs this is needed because you have to identify them somehow. For example, we create 3 coffees here, and later on we want to delete one again. So how to do this? And actually, when using hypermedia, you probably want to link some resources rather than having IDs and then later on concatenate the resources by the IDs on the client side. So what we want here is just an URI, which could be any URI. We don't inspect it, we don't want to change it, but we just need something to identify our resource. You could even drive it further and derive the URI to just a string, and which is then used on the client side or something else, or think of any other abstraction if you need it. But for now, let's do just the URIs here. So let's create these 3 URIs there and move on in our test. Let's say assert that coffees exist for 1, 2, 3. As I said, this method should then only test that the coffees exist without caring about any other resources that are there. So if there are more. And actually, if we do this in a method here, we can dive deeper and say, for example, create coffee, and then also verify or assert that the coffee exists in the same method. So let's rename this. To create an assert, which will then do the post and a get on the client side, and then here on the system test side, verifying that the data matches. And that's it. Now the next method, assert that the coffees exist. That should then retrieve the list of all coffees and assert that the URIs exist in that list. And that was this here. Now let's delete a coffee with these URIs 1 and 2. Assert that now the coffee is not there for 1 and 2, and assert that it's still there for 3. And that's it. That is our test scenario, including our data, what we want to test on the system side. So we created that up front, and let's finish these methods. And then we move on further 1 level deeper. Actually, let's call this assert found. So now, delete the coffee means delete coffee on the client side, obviously. And then it should be not found, which in that case, let's say it will be null later on, or not null in that case. So in order, actually that is the type and that is the origin. Okay, in order to move on further, let's create a client for that. And that is what I meant with the layers of abstraction. Everything on the HTTP level plus on the JSON request and response level is encapsulated in a client. Let's call it coffee client. And what we can do here is we can use a JUnit rule which enables you to do certain things. For example, access our test lifecycle and do some statements before, like asserting that our application runs or waiting for our application even, and so on and so forth. So this is why I very often tend to use these rules here. And let's create that client here. When you want to use a rule, you want to have a base class, for example, test rule or external resource. And then you could actually override methods like this before method, which then executes test code before your actually test method. And now let's move on in our test. Let's say we have the URI of the just created coffee when calling client create coffee from the type and the origin. Then we get the URI back, right? And then we can call like retrieve for the coffee, which gives us, yeah, that is the question. What do we get here? We either want to get something like a JSON object from JSONP, which encapsulates the data, or even encapsulate what we get into a separate POJO, like a coffee on the client side. And the point here again is that you should like decouple your client from your server, which means if you return, that is the server side here, if you return some data as JSON, like with these fields here, you probably don't want to have exactly the same fields in your system test accessing your client. And the reason for that is if you change something on the client side, then it should not be propagated all the layers up front and then fail on that other side, because you probably only want to make the changes down on the lower level. And another reason is if you include more data, which means if you enhance your REST endpoint with more JSON fields, for example, then this should also not affect your application. And actually that's also a good test, if you do so, that it still works. Okay, anyway, now let's create that POJO here. Only on the client side. I do not care about these packages right now. It's just as a showcase. And as you see, we can also use different not type safe types here. So different to that enum, for example, because the client may not be interested in these things on the client side. Let's create that just with getters and setters, and for convenience with extra constructors. So this will be then returned from the client side. And now to move further on, we take the coffee that we will get from the client side and assert, for example, that everything is correct here. Assert that the coffee get type equals our type we put in with the correct imports here from JUnit, and I use JUnit together with these Hemcrest matches, but actually this is just a side note. It doesn't matter which one you use, and that's it. We created the coffee, we retrieved the coffee back and asserted that it still exists, and now we want to return the URI that we get for later use. This is that on the system test side, and let's move on to the next ones. Client retrieve, for example, retrieve all, which gives us, that is again the question. So we either want to have a collection of URIs which just point to all coffees available or include more data. If you don't need more data here on that level or at that point, it's totally fine to just include a list of URIs pointing to all the coffees. So let's do this for now. Let's create that method as well. And then we can make sure, I think there is something like contains as a hemcrest matcher. That should be it. Which just makes sure that it somehow is contained here. No, actually that's exactly the wrong method. So this is what I meant before. If you assert this here on that level, you probably don't want to be that strict that you say the list must look exactly in a certain way, rather than it just has to somehow include all the instances we created here. I think it's called has items. Yes, that's the method we want to call here. So this just ensures that somehow all these URIs are there. All right, for the deletion, we will call, of course, client delete for the URI and make sure that it worked. So either that is a void method which returns an exception if not, or something else. Let's do that for now. It just deletes it and will throw an exception if it wasn't successful. And then we call client retrieve URI again, which should be then, let's specify that it should be null in that case. And in this case that it is not null. Actually, you could also get rid of these methods and include it here right away, but I actually like to stay on the same layer of abstraction even in a single class, so that you don't encapsulate the client calls here in one part and in the other part you do it directly. So actually I think this is more readable in your scenario test method. And now that's it on the system test side. Let's implement everything on the client side here. So in the before method, we instantiate the client here. New client with the target to, in that case, just localhost. You can also make that changeable for a system variable or whatever you need on your side. Resources, coffees. Let's do this. Oops. Let's create a new client and then create a base target here, which will be then used later on. So, for example, let's start with this method, retrieve all coffees here, which is the base target for request and request JSON. So media type application JSON and then get the response. And now the difference is on this layer of abstraction on the client side, we can do different type of assertions. So now we can really assert that everything on the HTTP level is fine right now. So we can, for instance, assert that response is in a certain status. For example, status OK. And encapsulate that as well in the method. Assert that response get status code equals the status code from here. Let's do the assertion and is. Because we can need that later on. So now we retrieve the response, assert that it's 200 okay, or actually we could also be even less strict and assert that it's just somehow successful, and then return the response read, actually, which is in that case a JSON array. So we could either use something, a POJO, which then is automatically mapped from JSON to the POJO, or just use JSONP to programmatically read what we get back here. So that is the JSON array, which is a JSON array returned. And now we can ask the JSON array to give us the values as JSON objects and stream them, which is then a stream of JSON object. This will, here for that example, be a JSON array which contains JSON objects that look like follows, which means they all have a JSON object with the _self property, which we will now access. So this is the object get string from _self, and then map that further into a URI, and then collect that into a list and return it, which will give us a list of URIs. So map it to the self URI string, map that to a URI and collect it. And that's what will be retrieved on the client side here. For retrieving a single resource, we need to get the client with a new target from that URI and request it as well with JSON. And read that again with the status OK. And now we want to create this new coffee object with the type and the origin, which means we need to read the JSON object again from the response, and then call and get the type and the origin here from the response. We could also first verify that's available there and even verify some more low-level data, but actually this will also fail if it's not available. So by doing so, we are only relying that these two fields are available and that it's somehow mappable into a JSON object, which is quite strict on the data which we need, but quite liberal on everything else. So everything else on the JSON object side could change without breaking the test, which is actually what we want, because we don't want to be overly strict and overly coupled from the client to the server side. And now for the creation, we have the base target again, make a request, and this time it is a post, and we are posting a JSON data here, which we can actually return just from scratch. So either return and create a coffee object, or just make it here in a programmatic way. It actually doesn't matter, with the type that we have here and the origin, and build that into a JSON object. And just for readability, let's make a separate variable, and while posting we have the response again. We assert that the status in this case is created, and furthermore we assert that the response has a location, because this is what will be returned from the server side, 201 created plus a location HTTP header pointing to our newly created coffee, which we need later on. So that is the location. We now assert that it's not null. We can also, that depends on how tightly you want to couple that, assert in a certain way how the URL looks like. Normally I would say don't couple the client and the server too much, but for example you want to make sure that the rough structure is somehow given. But actually there's no real benefit in doing so. So let's leave that for now, and we return the URI. And a similar thing is done for the deletion. We get a new target of that URI of our coffee and say we want to make a request, in this case a delete, get the response, and just assert that the response is in a successful status. In that case it's, sorry, no content, 204 no content, so it was deleted successfully. And that's pretty much it on the client side. So now we have our acceptance test up and running, and our application is still running here. Therefore we can just start the system test and hope that it works. So let's start it for now, and maybe it works, and if it doesn't, it's even more interesting, because then we can just see what didn't work. So assert that the status for some response didn't match. We can actually look where that came from and look further on, as we have these several layers of abstraction, where it failed. So it failed just right at the beginning. When we created it, it says 204 for creating a new coffee. Assert status created. Actually this should be the case. Let's see what was done here for creating a coffee. Oh, actually we did, we forgot two things, and this is, I didn't plan that, but that's actually even more interesting, because now we found an error in our application. Not an error on the logical side, but on the implementation interface side. Because when creating a coffee, now we say just 204, which is fine, but 201 would be even better, because the status code tells you in a more exact way what was done on the server, namely that you created a new resource, 201 created, and it also directs you where that new resource is, which is needed on our side. So actually we changed the application code, because it should return a response, which then is created from a URI, and that URI comes from the EJB that is called here. So create coffee. Oh, actually that is interesting, because it's not there. It's, create coffee creates a new coffee and inserts that into a map. This is just done because it's a simple example. What would else be done on the database level or somewhere else? And that is done via an atomic long. The reason for that is that we can use a singleton with bean managed concurrency, and actually that will be the ID which we return here. And this is what we want to return from our JAX-REST resource. So we get the ID back from our EJB when we call it, and we can use then our nice URI info functionality to create the IDs programmatically in a similar way, which I have done down here. So let's copy paste that for now and return the URI, and just return that in a response with the created status code. So now it actually should work. In order to do so, we can rebuild and redeploy our project, and then we can just restart our acceptance test again. So in a more sophisticated test, you could also enhance your client at Oh, actually this might be because it wasn't there yet. This can be the case. Let's restart it again. Oh yes, that is actually an error in a test. So what I did, I created the public interface of a client as such that the retrieve should return a coffee or return null if it's not found. And actually let's enhance that if response status here equals not found, then return just null. That is what we want on that side. But as you can see, while running our test, we got quite far. So all of these methods worked. And what I said before, if your application is not there yet, if you run your test, so for example, if you build and deploy your application and that takes a while and you start your test immediately, then, and that is the nice thing about these JUnit rules and external resources, you could even wait here, which means that you do a poll to your URI to a specific resource, for example, the base URI, and then poll that long until you get a 200 status code. So you could do a request with head, HTTP head, just to get something back, and if it's 200 okay rather than 4 or 4, for example, then you know that the application on that specific resource and endpoint is up and running. But for now, this is sufficient. Let's run our test again. Let's see if we see another error of, oh, no, it works that way. And actually, this depends on what you want to do on your system test side. So either you did what I did here and just assume that the application is being used in the meantime anyway. So you can just create some resources and do not care whether there are others or whether that is cleanup at the end, or you include a cleanup with an after method which deletes everything on that side again. So you have a clean system test. But actually it doesn't matter if you just fire up a system test like in a specific environment or in a Docker container, and which can be just deleted afterwards again. So was the exception from our failure before. Actually, just to see that all these coffees are still there, let's retrieve that again. And you see that these are still there, which weren't deleted. So that was actually the third one that was always created and not deleted on that side. So you see that the system test actually works. So did I just maybe I forgot to switch back the video. So here in that case I accessed it again. So this is how you do system tests in both a technical level and both how to structure them in a way that you can change things on your application side and manage your test data and test implementation in a somewhat productive way. So you can write fully fledged end-to-end test without needing to spend a lot of time in maintaining the test data or maintaining the implementation. However, the most important thing to consider is, and that is always true for all kind of tests, that you make sure you do a reasonable layer of abstraction when designing your test, and even more important, that you use clean code as a whole when writing tests. Which means your test is obviously not production code, but still it's very recommended to follow the same clean code rules to having a maintainable test and also a good readable test. Because when test code is treated as poor relations, then, well, the tests get abandoned or ignored or just removed with add ignored later on without being fixed when they actually contain readable and maintainable code. So at the end of this year, I'm offering workshops in both Munich and Oslo, and actually there are 2 whole days about the whole testing topic. So I will cover similar things that I showed in this video, with a whole unit integration, system acceptance and performance test and so on and so forth. Also going further on into a continuous delivery pipeline with having automated verification of enterprise applications. So I hope you enjoyed the video. Thanks for watching, and bye.